An ISO cryogenic container sitting in a Persian Gulf port. Inside, liquid helium at -269 degrees Celsius. For every day that container does not move, between 0.2 and 0.6% of its cargo converts to gas and is lost. No cryogenic container in the world can store liquid helium for more than 6 weeks before cumulative loss pushes the shipment out of specification. The Iranian attacks on Ras Laffan in March 2026 did not create the helium crisis. They exposed the physics that was always there. According to Air Products and Linde datasheets for high-performance ISO transport containers, liquid helium loses between 0.2 and 0.6% of its cargo per day. Effective holding time before cumulative loss compromises the shipment is 20 to 40 days. LNG, by comparison, has a boil-off rate of 0.10 to 0.15% per day, per the IGU World LNG Report 2024, slow enough to permit strategic stockpiling over months. Helium does not allow that strategy, and the reason comes down to the atom itself. A helium atom is small enough to slip through seals that hold every other industrial gas, light enough to escape Earth's gravity once released into the atmosphere, and chemically inert, so it forms no compounds that could trap it back into solid form. The second most abundant element in the universe is, on Earth's surface, one of the hardest to retain. 2 attacks in sequence. On March 2, 2026, Iranian drones strike Ras Laffan. Qatar Energy suspends LNG production. The helium market tightens, but holds. Distributors are still drawing on buffer inventory inherited from the 2024 to 2025 oversupply. 16 days later, on March 18th and 19th, Iranian missiles cause extensive damage to the infrastructure. Qatar Energy declares long-term force majeure. Minister Al-Kabi confirms losses of $20 to $26 billion annually and up to 5 years of repair work. Official 14% drop in Qatari helium exports. Even a partial restart would take months, not weeks. The helium supply chain does not recover on ceasefire timelines because every container in transit during a shutdown has continued losing 0.2 to 0.6% of its cargo per day, every day, regardless of what happens at the wellhead. There are 2 clocks running. The channel clock belongs to the distributors. They entered the crisis with above-normal buffer inventory inherited from the 2024 to 2025 oversupplied market. Multiple analysts project depletion between May and July 2026. The fab clock is faster. The Taiwan Semiconductor Industry Association reported inventory sufficient for a few weeks, with shortages beginning in the 3rd week of the war. Taiwan holds no strategic helium stockpile. On current trajectory, the 2 curves cross between May and July 2026. That window is not a forecast of collapse. It is the arithmetic of how long the buffer lasts if no new helium enters the system. 2 clocks. And underneath them, 4 systems running on the faster one. Inside the etch reactor, the silicon wafer sits on an electrostatic chuck. Helium flows underneath at pressures between 2 and 20 torr, documented in applied materials patents, transferring heat from the wafer to the chuck during the process. Without that flow, thermal uniformity across the wafer collapses and etching loses nanometer-scale precision. Hydrogen offers better thermal conductivity, but has not been adopted in production due to ignition risk under chamber conditions. No fab in operation uses a substitute. Cooling is one function, vacuum is another. Inside an advanced fab, every process tool is a vacuum system. Helium underpins their integrity in 3 ways. As the smallest atom in existence, it is the only practical leak detection medium. A vacuum chamber that cannot be tested with helium cannot be trusted, and a single undetected leak destroys the entire wafer batch in process. Silicon scrap measured in tens of thousands of dollars per chamber, per cycle. As an inert gas with no chemical reactivity, helium provides contamination-free atmospheres where reactive gases would ruin the process. And in select chemical vapor deposition and atomic layer deposition recipes, it functions as a carrier gas for precursor chemistries. 3 uses, 1 underlying property. Helium is the only gas the vacuum can trust. That covers the chambers. The lithography tools that pattern the wafer face their own helium dependency. Helium cools the optical systems in ASML's EUV lithography tools, the bottleneck machines that enable production at nodes of 3 nanometers and below. Without sufficient cooling, the optics drift out of alignment, and the photolithography step that defines every transistor on a leading-edge die fails. A drop in helium supply is a direct drop in advanced node production capacity. ASML's EUV tools are already the rate-limiting step for every fab producing leading-edge logic. That is the 3rd use. The 4th one is about what happens to the helium after it has done its job. Advanced fabs operate helium recovery systems. But recovery is not a closed loop. Every cycle loses helium to vacuum pumps, exhaust dilution, and chamber purges. The capture rate is significant, never total. Per fab consumption volumes exceed any stockpile that is physically viable at the facility level. The Semiconductor Industry Association warned as early as 2023 that even a short disruption would produce shocks to the global semiconductor manufacturing industry. Taiwan sourced 69% of its helium from Gulf Cooperation Council states in 2024, per Barclays via CNBC. South Korea imports 64.7% of its helium from Qatar specifically. Qatar accounts for roughly 30% of global helium supply, per USGS. Russia, once a meaningful alternative through Gazprom's Amur plant, has been structurally unable to compensate since the 2021 fire. This concentration is the symptom. The underlying failure is one of classification. Companies that managed helium as a strategic utility are absorbing the shock. Those that treated it as an ordinary procurement line are now exposed. That gap is correctable through procurement governance, but it cannot be corrected on the timescale of a ceasefire. GasWorld publishes a quarterly helium confidence index based on surveys of distributors and integrators across the sector. In October 2025, the confidence reading stood at 32%. In March 2026, after the attacks, it fell to 18%. Declared concern rose to 52%. That confidence number is not a sentiment score. It is a direct reading of how close the 2 clocks are to crossing. April 2026. Distributors project inventory depletion between May and July on current trajectory. Advanced fabs operate on weeks of buffer, not months. When the 2 curves cross, the shortage moves from balance sheet to production line. Helium is the first industrial test of a non-substitutable input with extreme geographic concentration. Gallium, neon, and refined tungsten share the same 3 characteristics: non-substitutable function, supply concentration, and impossibility of large-scale stockpiling. The logic will repeat. The only open variables are which input and when.